Hello, welcome to assignment 3. This assignment is about regular expressions and some tools we can use in the Unix terminal to use our expressions. Regular expressions are used to match some patterns in everything from small text files to large data streams. Most often text. As we can see here on this very long example, it's pretty hard to distinguish what is what in this. The best way to learn regular expressions, in my opinion, is to use another tool such as Regex 101. It's an online editor that can help us understand the different parts of an expression like this. The assignments are two parts. It's the first part is said, or the second, depending on if you look at exercise or assignments. Said is a tool we can use to process text line by line, and it works very well with regular expressions. So SED stands for stream editor. We can, as the name suggests, we can edit the stream of text. Then we're going to look at awk. Awk is a bit bigger command line tool, as well as it's almost an own scripting language. So for awk we have a bit bigger guide. Look at all parts, use it just as you use the bash guide as a reference if you want to look up something. Let's get started. The reason we are learning regular expressions is both it's fun and it's very useful to know, at least get a hunch of it, so you can manage to process text. Some stuff like Atom editor. I don't know if you use VS Code or Atom. In Atom you can search your buffer, your project, with regular expressions if you want to change some variable name to something else. You can easily do that with regular expressions. We start with SED. If we look at the exercise, we have, it's a part in the guide as well. You don't have to worry about this part, regex in bash. It's an old lab. It's built in bash, regex. It's a different engines that triggers and parses your expressions. And bash has its own. SED has its own. And as we're gonna see, different flavors and dialects of regular expressions. Use this. It's not much, I know. But with the help of this first one, special characters, and matching, here we have character classes and such. With the help of these and the Regex 101, it's enough to get started, and it's a lot of trial and error to move forward in the labs. Try something, it doesn't work, then you try something else with the help of the guide and the online tool. Okay, this text file is available in the course repo. I copy that and I paste the content here. So this is what we have to work with for now. And as I mentioned, there are different flavors of regular expressions, different engines that parses it. So here we can see we don't have sed or bash or anything. Java, Python, JavaScript and PHP. That's why when you try something here, it's not a one-to-one mapping to sed. Okay, let's get started. The most basic part is to match a whole word. Let's say the word teacher. We can see here that it matches on each line. It's just the word teacher. We can see here to the right in the explanation that teacher matches the characters in the word teacher literally. Case sensitive. Let's say we don't know the whole word to teacher. We only know TEA. And we want to match the whole word. There are different ways to take on this problem, but the most common and useful is to use a character class. It's the brackets, and inside here we can type ranges or just different letters. Let's say we type REC. E is already part of it. Too much. Yeah, we take one at a time. TEAC. Then we can see we matches the C as well. And we can add some characters inside here. The C in age, then it matches TEA and C or an age. And we don't have any word with TEA age, but if we want to continue to match the word teacher, we can use the plus. The plus, as we can see here, is a quantifier, and the quantifiers repeats the previous pattern a different amount of times. So this one says start with TEA and then a C or an age one or more times. So let's say we have the word TEA. Yeah, like that. One or more times. There is no upper limit. So TEA followed by any one of those letters one or more times. Then we're gonna match it. Quantifier. There are several quantifiers. We have a star. The star is 0 to unlimited amount of times. Also works in this example. We have a question mark. Is either it's there or it's not there. And then we can continue with our expression here. So TEA followed by perhaps a C or age, but it doesn't have to. Okay, back to character class. Let's say we want to match any character, or any, any letter. Then we can specify ranges, A to C. Perhaps we can remove that part so we can see the whole. Here you can see we matches everything except capital letters, spaces, and numbers and parentheses. It's just A to C. And we can see by the different color codes that it matches only one character. We add our quantifier one or more times, then we immediately get some more words, but we don't get the part where it's a capital letter. If we want to catch those as well, just type capital A to capital C, or sed, perhaps. Then we matches all the letters, And one difference is if you Google character class, you are going to see the other way around, A to C, that one. And capital A to lowercase c, said, is all the letters, A to C, capital and lowercase. It's a shorthand for the one we had before. This doesn't work in Z. Is one of the things that doesn't work. So when we want to use everything, type it like that. We can also have a shorter range. If we want only capital letters A to D, we have a range defined by the hyphen. We can see it doesn't match the K, the E, the M, O, P, only the D and A. So it's a range. Let's say we want to match the space as well. If we want 2 words, we can just add the space inside. Then it's gonna match something in this character class, and the space is literally a space. If we want to match a space outside, we have to escape it with the letter S, because only the letter S matches the letter S. So if we want to mark it as a space, we have to escape the character. And this has to be done on several parts if you want to do it outside of a character class. That's why I say I think it's better to use a character class. It's more clear. The code gets more readable when we know that what you type in there is what you type. It matches what you type. Okay, back to character class. Inside here we can also use dot. As you can see, we matches the dot or the period. If we type a period outside, it's any character. We can see here, matches any character except for line terminators. And that's the, you can see the enter sign here. It's a line terminator. If we want to use a dot outside of a character class, as you already guessed it, we use escape. And when we use escape, we can, in most flavors of regular expressions, we can use some shorthands like W. Here we can see it's equivalent to A to C 0 to 9 is a range of all the numbers, and underscore. This part, this \W, is a question I get a lot. Why isn't it working instead? It doesn't work. I'm sorry. Instead, write A to C 0 to 9, and that one, if you want to match an underscore. We don't have any underscores, so it's pretty meaningless here. Okay, character class. Let's go back to quantifiers. We want to repeat this structure a defined amount of times. We can use an interval, and in here we can type either a number, 2, then we can see by the color codes we only matches 2 letters. We can use 2 to 3, from 2 to 3. We can use 2 to 5 perhaps. Yeah, it's a interval. If it's at least 2 or more, then we don't have to define the upper limit. So this is an interval. And this is also a part where it can break when you move it to Z. Because there we have to escape the curly brackets if we want this to work. I will show you how you can do it instead. Let's try to find something that is only on one line. We take this one, it's on 2 lines. We match just the capital O 2 times, and there we have it on this row and on this row. Then we move to the terminal. We copy this and we go here and we go into the example folder. Oh, we don't have sed here. Okay. Then we create the one, and we take this text, and we paste it, we save it, and now we have it, and we can work with it. To invoke Set, we use sed, we call the command, so to speak. Then we have small quotes, small single quotes, to mark where we want our pattern to be. We add some delimiters. Here we can have exclamation marks if we want. We can have the letter W if we want. It's not to recommend because we use it otherwise. A normal slash is the most common. It's fairly easy to see where the parts get divided, and we don't have spaces in that much text. Okay. In the end, we will mostly use P. It stands for print. We want to print our result. And we can just paste our example here. It was O, and it was like that. This is how you invoke Set. But if you run this, we only get all the files, all the rows. It's not just the rows that we wanted. It doesn't work. Because when we use print, we print all the lines. Set works line by line, and we print them. If we just want to print the lines that we have a match on, we use the option N. But now when we run it, we don't get any result. That is because we have to escape the curly brackets if we run the command like this. And now when we run it, we get the desired result, the rows with capital O. But as you can see, or imagine, when we have a larger expression, it's going to get pretty messy if we have to escape all the curly braces and parentheses and everything. Luckily for us, we have one more option. It's capital E. It stands for extended regex. And with the use of that, we don't have to escape as much characters. Okay, so that is one part that you have to fix when you move from Regex 101 to the terminal. Use capital E and N all the time, so you don't have to worry about it. So you have questions inside your SED lab. Do them one by one, and I think you should manage with the help of the videos that's already in the playlist and this one. You can look at the lab and see if there's anything more to talk about. You create it, you invoke it, like the commands before in the labs. Yeah. Some tips. A bit down in the SED lab, there's a question about Thor and his file system. You are not meant to create these paths, these folders and files. It's merely text from a text file. I think it's this text file. The result should only be a printout. So you use P. So you're supposed to print the desired result, not create the folders. We have to look at substitution. We can do it here, perhaps, or no, we do it here. Let's say we want to change the word teacher to another word. Then we can trigger the substitution with S. I should be inside. And one more part, delimiter. So on the left hand, we have the word to, or the pattern we want to change. I'll make it easy for me and just type teacher. And to the right, we have what we want to replace that word with. I can just take some capital M's so we can see the change. And as you can see, it matches all the lines because all the lines has the word teacher, and it replaces the word with whatever I type here. And when you work with substitution in the lab, you're most of the time supposed to capture something, some part, and then you use that part here. So you only type out the things you matched, not the whole lines. And to be able to do that, we use groups. A group is defined by parentheses. And inside here, I type the pattern I want to capture in my first group. Let's say it's the word, what should we take? You can take the word course. Course. And then, if I reuse the group, this is in the guide as well. I capture the word course, and I reuse that group with \1. Because it's the first group that I've captured. And now we can see we get the whole line. And to filter out anything else, we can use .star. Because a dot is any character, a star is 0 or more times. So it's a bit dangerous to use it, but it filters out anything else. So now we only get the word that we look for. Because here we say parse everything, whatever it is, until we reach the word course. Is here. Then we capture course, we put it in a group, and then we have .star again. And that's anything to the end of the line. So this way you can filter out everything. We can capture more groups. We can say if we want to type out the course code as well. 0 to 9, 1 or more times. That's group number 2. And then we can reuse it here. Okay, it's greedy, so it only takes the one part. If it finds one, it takes just the one. Or lazy, perhaps is a better word. We want to catch all the whole course code, and it's 4 digits. Oh, we also have to remove the last part. Like that. Now it only captures the word course and the course code. As you can see, just to do this, it's a fairly long expression. So it's gonna get big and a bit messy. And it can be hard to distinguish where it went wrong. So take one part at a time. Like we did here. First, let's try to find the first part first, and then you move on to the next part of the question, or the desired result. So it doesn't get so messy. We don't have to use them in order. We can reverse them. So this is groups, parentheses. And we can reuse them. We can remove everything else with dot star. Okay. That was said, and some basic regular expressions. Use this one because it's very good and it explains everything here. All the parts that you type, and you can see exact matches here. And then you just have to tweak it a little bit to make it work in Set. We're also gonna work with awk. And awk is another command line tool that works line by line, and it really shines when it comes to comma separated files like Excel files or CSV files. We can work with the output. Most of the time you work with the output. So you have a big file or something and you want to structure it and make it look nice. And we do that with the help of awk. We are not gonna go to the depth in awk, but we're gonna learn enough to be dangerous. If we look at the guide, we have it somewhere. This is said, get started with awk. Here we go. It starts with how to install awk, or gawk is really called, is GNU awk, because we try to use the GNU tools as much as we can. Some information on how it works. Okay, this is in Swedish, I can see. We have different blocks in awk. So the first block is begin. That is what's gonna happen before we dig into each line in the file. And then we read rows from the input, and we execute commands on the row. We can set delimiters on how we want to split it. And then we can, just like arguments in bash, we can use $ and a number to pick just the part we want to work with. And if we are not in the end block, we repeat this stuff on the next row. And then we work our way down, and then we have an end block. And in the end block, we can work with something after all the rows has been parsed. Okay? Read, execute, repeat. Here we have the blocks. Capital letters begin, followed by curly braces. And the curly braces marks where the block is. This is not news to all of you, I think. We have the middle block. If we have a pattern, we put it here. We are going to use very little regular expressions in the awk part of the assignment. And then we have the end block. There are the awk assignment is, are you going to create 10 9 or 10 awk scripts, and you're gonna filter out from a very big file of names with addresses and birth numbers. And it's stated in the text or in the assignment, but I say it here as well. I have randomly generated all the names. I took a public list of the most popular names, the most 1,000 popular names, I think it is, first names and last names. I've created a random generator to generate the birth numbers, and the cities I took from, I think it was a list on Wikipedia or something. So it's not connected to any real person. If it matches someone you know, it's just by coincidence. Everything is randomly generated. So no one's gonna argue with me on that. This guide starts with printing and using awk without a file. And like this short example is not so exciting. We're just printing the word some text. But we have a begin block. We don't have any file or rows to work with. So to be able to do anything at all, we have to do it inside the begin block. But this is not the exciting part. It's a bit further down when we come to a script file. I think something is missing here, because here you create the file and you open the file in an editor. It's the awk script, sorry. Phones.txt should be inside here, so you have it to work with. And to trigger it, as we saw, we use the option -F. We want to use a file. And which file do we want to use? Oh, we haven't created it yet. But here we type our script file. And then the file we want to use. So we have to create phones.awk. Let's do it. Touch phones.awk. We open it up and we take this one from the example and we paste it. Here we have a shebang, and it's a way to make the system use the right version of awk. It's very backwards it works with a lot of versions of the terminal or the Unix system. Here we can see the begin block, and then we have the commands we're going to do on each row. It's all the way down here. So all these parts, fs is a field separator. Here we can define what we want to use to separate all the words on the line. If we look at the file, we can see it's a typical CSV file. This is comma separated, so it should be fairly logical to separate every row field on a comma. And that's what we are doing here. We set the field separator to a comma. Output field separator. What should happen when we print, when we're working down here, when we print our result? What should we have as a delimiter then? Default is space, but we can change it ourselves. We can start by out-commenting it. NR is the row number. So if the row number is 1, the first row, just move on to the next one, because we don't want the first row. And what are we going to do with each line? Yeah, here we only print first the second column, followed by the first column. Let's run this and see what happens. Awk -f phones, and then we have our awk script and our text file. Go. We skips the first row. The first row was this one. And we split it on comma. And we can see that we have here is $1, $2, $3, and $4 on each row. And in the script we print $2 followed by $1. So there we have the second one and then the first one. I think you all recognize this from the arguments in Bash, in the Bash scripts. So that should not be news. If we want to do something in the end, we use the end block. And here we can, this is the end. We save it, we run the script again, and then when all rows are parsed, everything's done, then we pop into our end block. And it could be nice to work in there, in the end block, when you want to calculate something on all rows, or perhaps create a total of some sort. Then you can work with the rows or the values, and when you reach the end, you have access to the whole calculation. A small tip. I think there are some exercises where you should work in the end block. I don't think I'm gonna go that much deeper in here. We can look into the guide and see if there's something I have to clarify. And as we can see here, it's used to create an output. A fairly nice looking report in the terminal. And in the end, here we can also put the result straight into a file, or a JSON file perhaps, if we want to work with a CSV file, do something with the rows, create a nice structure, and then we can push it straight into a JSON file. That's nice. You should have everything you need in this guide. So look at each part, try it in the terminal, create the scripts, paste the code, and run the scripts. So you can see what it does. And you can try and change stuff yourself. It's a good way to learn. I think one strange part, or a new part perhaps, is the printf and the padding. This is perhaps the hardest part. It shouldn't be, but it is, and I think it is myself. It's very hard. In the assignment it says that the output should match. Do your best, I say. No one's gonna fail you on the assignment if you are close to what is asked. Because I know it's hard. Do your best. Are you close? You're gonna pass. If we can see that you have tried. But if you manage to solve the first parts, I think you should be able to solve all the parts. Make sure you're using GNU awk and that you work inside your virtual machine in Debian. Okay. Use this as a reference. The padding part, the output, is also a bit trial and error. Try to change the padding, see what happens, and tweak it until the output is okay. Awk is a built-in programming language, and it has its own built-in variables. We're not going to look at everyone, but we have 1, 2, 3, 4. I think you're going to use perhaps 2 of these inside the scripts. But you should know that there are built-in variables. There are also built-in functions. I hope we have the functions here as well. Yeah, like this. We have int. You parse it to an integer, the result. It's a built-in function. There are some more you're gonna bump into. But overall, we are only scratching the surface. We are not gonna go that much deeper in Awk. I leave it here. That's the thing you're gonna do. The extra assignments is JQ. JQ is another command line tool. You have to install it. And if you go to the instructions here, the guide to install JQ, you have everything you need to be able to solve that lab. But it's optional, it's an extra assignment. You don't have to do it if you don't want to. I'm not gonna dig in and show you how it's done. It's started just like Sed or just like Awk. You invoke it with the command, with the name, and then you can work with some file or whatever. Awk and Sed and regular expressions. You have 3 videos in the playlist before this one, where we talk a bit about regular expressions. It's in Swedish, but for those of you that don't understand Swedish, you can turn on the subtitles. And I hope it should be alright. You have the whole internet to your, what's it called? I think you're gonna manage. It's hard, it's a bit of a threshold to get started with regular expressions, but when you get a hang of it, it's a lot of fun. It's very powerful, and yeah, it's a good thing to have on your resume. You can tick the box, I know regular expressions. Let's see you on Tuesday. And I hope you all get started with this assignment and that you find regular expressions as fun as I do. Bye bye.